Imagine an engine so powerful, it takes a $2.5 million supercomputer just to turn the key, but once it's running, you can rent it to build entire software ecosystems for literally pennies.
It's completely wild to think about.
Right. Well, that is the paradox of Kimi K3. Welcome to today's Deck Dive. Our mission today is unpacking Moonshot AI's 2.8 trillion parameter model. We are synthesizing, technical blogs, API docs, and benchmarks to show you why this upcoming open-weight release is a massive paradigm shift.
Yeah, and it's rivaling heavyweights like GPT 5.6 Sol and Claude Fable 5, but doing it with a totally different approach to public access.
Exactly.
To understand why K3 is turning so many heads, we really have to look under the hood at its architecture. It uses a mixture of experts or MoE setup.
Oh, okay, so how does that actually work?
Well, out of its 896 neural experts, only 16 activate per token.
Oh, wow. So just to make sure I'm wrapping my head around this setup, is it basically like triage at a hospital?
Yeah, that's a great way to put it.
Like if I hurt my knee, I'm only routed to the orthopedics department. I don't need cardiologists or neurologists weighing in on a torn ACL.
Exactly. That selective activation is the secret sauce. The system routes the problem only to the specific parts of the network trained to solve it,
Right.
which is how it achieves frontier-level intelligence
Yeah.
without, just melting down the servers.
Which brings up the highly anticipated July 27th open weights release. And I have to say, when I hear open weights, my first instinct is to try and spin it up locally.
Oh, I mean, good luck with that.
Yeah, right. At 2.8 trillion parameters, even with their new MXFP4 data compression, this isn't fitting on anyone's home rig, is it?
No, not even close.
Yeah.
I mean, that MXFP4 compression is amazing. It essentially reduces the mathematical precision of the model's memory just enough to save space.
Okay, so it shrinks it without losing its core logic.
Right, it shrinks the weights down to about 1.4 terabytes. But to actually run this model, you still need a data center grade cluster. We're talking 64 or more high-end GPUs.
Wow, so a hardware setup costing around $2.5 million?
Easily, yeah.
So while the weights are technically open, deploying it is a massive infrastructural undertaking. But, I mean, if it takes a supercomputer to run, what exactly is it capable of doing for you?
Well, it excels at long-horizon agentic workflows.
Yeah.
K3 has a 1 million token context window.
Wait, 1 million? That's huge.
Yeah, it means it can hold massive code bases in its working memory all at once. In one benchmark, it autonomously executed a 122-step legacy coded migration.
So it didn't just, write a script.
No, it planned the whole migration, executed it step by step, and verified the results, totally without human intervention.
That's insane. And the visual coding examples in the sources are wild, too. It built a fully functional macOS clone running inside a browser and a 3D cyberpunk Spider-Man game complete with rope physics.
Yeah, the physics part really got me.
But I have to play devil's advocate here. Is the AI genuinely designing these things, or is it just, copy-pasting existing code from GitHub?
It's a fair question, but the Armory beta test proves it's doing way more than just regurgitating templates. Reviewers asked K3 to design a 3D sci-fi weapons room. It didn't just place 3D weapons in a generic box. It actively designed the lighting, like installing atmospheric red warning lights to match the specific sci-fi context.
Oh, I see.
Yeah, it demonstrates true contextual understanding and spatial reasoning.
That level of autonomous reasoning is incredible, but also it's a terrifying double-edged sword once those weights become publicly unrestricted.
Absolutely. Because unlike proprietary US models that have strict safety filters blocking hacking-related prompts, K3 has zero safety filters.
Zero. And just to be clear for the listeners, we're just impartially reporting what's in the documents here, not endorsing it. But that is a massive detail.
It's huge. During a deep audit test, the model actually deployed 25 sub-agents to scan an entire cloud infrastructure, just hunting for vulnerabilities in parallel.
It's the ultimate dual-use dilemma. On one hand, it democratizes enterprise-grade defense, right? Allowing a small startup to secure their servers like a Fortune 500 company.
Right. But on the other hand, it hands hackers a tireless automated tool for finding zero-day exploits. The tension there is undeniable.
But K3 does prove that open models can match the closed corporate giants.
For sure. And if you bypass the hardware barrier by using their API, they use aggressive caching, which remembers previous parts of your prompt to save processing power.
Oh, nice.
Yeah, it drops the cost for these complex tasks to just 30 cents per million tokens.
30 cents. That is just unreal. Which actually leaves you with a fascinating and A somewhat unsettling question to ponder on your own.
Oh boy, what is it?
Well, we know deploying this brain requires a $2.5 million server cluster right now. But what happens when open source hackers bypass that physical hardware limitation through crowdsourced, decentralized compute networks?
Wow. Yeah, that changes everything.
Right. We might soon be looking at a world where an unrestricted, hyper-intelligent agent is roaming the dark web, powered by thousands of borrowed graphics cards, completely outside the control of any single corporation or government.